RQSIM, Scientific Computing Library, Heat Transfer Library, notebook number 3. This is about the lithium-ion battery thermal runaway. Version 1, author Loredo Aguilar. Notebook 3, lithium battery thermal runaway. We have the introductions. Uh, Thermal runaway in thermal ion battery is a dangerous failure where an uncontrolled self-accelerating increase in temperature leads to fire, smoke, toxic gas release, or even explosions. So we have the normal operation here versus uh, runway. So normal, when you charge or use a lithium battery, it naturally produces some heat. This is normal, and battery designers are cooling mechanism to get rid of the heat. So the runaway, the battery produces heat faster than it can rid of it. Because of this build up, the inside of the battery heats up to extreme temperature of in between 600 Celsius and 800 Celsius, or 1112 Fahrenheit to 1472 Fahrenheit. This extreme heat causes a cascade of chemical reaction that produces even more heat. The three stages of failure, the chain reactions. Stage one, onset, the trigger. Something causes the battery to start overheating. This could be an internal defect or an external cause, like physical damage, overcharging, or being exposed to intense outside heat. Now, stage two, for the acceleration, the meltdown as the heat builds up, structural safety elements fail. The separator plastic layer that keeps the positive and negative parts of the battery apart melts. So this allows the battery to short circuit. The SAI layer, a protective coating on the battery's anode, breakdown, exposing reactive materials. The electrolyte, the liquid that carries the electric charge, starts to decompose. So this process releases more heat and produces highly flammable gases. So stage three, full runaway. The critical incident. This is the dangerous climax. The materials in the battery's cathode positive electrode uh, releases pure energy. Pure in a fire, oxygen acts as the fuel. Because the battery is now creating its own oxygen, it effectively provides its own fuel to keep burning intensely. This leads to venting. Toxic gases explodes out of the battery. Fire, the electrolyte, and the internal components ignite. The propagation, the extreme heat spreads to neighboring cells in the battery pack, causing them to enter thermal runaway as well. So why is this a big deal? So unlike a campfire that needs outside air oxygen to keep burning, a lithium-ion battery in thermal runaway produces its own oxygen internally. So this makes the fire incredibly difficult to put out without, with standard extinguisher, and they can spontaneously ignite if the battery pack is not completely cooled down. So the four main triggers, how it starts. So the thermal runaway does not just happens randomly. It is usually set up by one of four specific types of abuse or failure. Uh, Mechanical abuse, physical damage. This happens when a battery is physically crushed, bent, or punctured, like in a car crash or dropping a phone hard. So this physical force breaks the internal layers, causing a short circuit that immediately generates intense heat. So we have the electrical abuse here, but charging. So this happens when a battery is overcharged, pump full of more energy than it can handle. Under the charge drain completely empty or short circuit externally. So this electrical stresses causes the internal chemistry to stabilize. So we have the thermal abuse, external heat. If a battery is left in a hot car or placed near a fire, the external heat overwhelms the battery's ability to cool itself down, starting the chain reaction. We have the internal defect, manufacturing problem. The battery is made in factory and tiny manufacturing flaws can exist. So things like microscopic metal contamination, tiny wrinkles, or dendrite growth, spiky microscopic metal crystal that grow inside the battery over time can pierce internal barriers and cause a short circuit. The domino effect, once one single cell in the battery packs, like in an electric vehicle, starts overheating, it creates a severe domino effect. The extreme heat from that one falling cell radiates to the adjacent cell next to it, causing them to heat up and melt off. So this turns a small isolated failure into a large scale catastrophic incident like the EV engulfed in the flames. So how modern batteries try to prevent this? Because these batteries are used in everything from phones to cars to power grids. Engineers have developed a defense mechanism to stop this from happening. We have the battery. Number one, we have the battery management system. So a small computer chip inside the battery, okay, that constantly monitors temperature, voltage, and current. It shuts the battery shut down if it senses danger. And we have the number two. We have the bitter chemistry, uh, and lithium iron phosphate batteries. So this is a specific chemical composition that is naturally much more resistant to catching than older NMC, nickel manganese cobalt battery. This is why EV manufacturers are switching heavily to L- LFP. We have the cooling system, liquid or air cooling system actively remove heat during rapid charging or EV use. So we have the venting safety valves that intentionally pop opens to release flammable gases before the pressure gets high enough to cause an explosion. So the takeaway. So this section concludes that thermal runaway is the primary reason lithium-ion batteries catch fire, because we rely on them so heavily in modern life. Understanding this triggers and continuing to improve safety features is a vital area of scientific and engineering research.